Yeah, okay, cool. There's a strange printer with defined two special requirements. The printer can only print a sequence of the same character each time. At each turn, the printer can print new characters starting from and ending at any places, and will cover the original existing characters. Given a string consists of lower English letters only, your job is to count the minimum number of turns the printer need to in order to print it. Cool. Uh, okay. Not quite sure I understand this question, to be honest. That's why I'm like looking at examples really quickly. Uh, two. What's a turn? Each can only print. So it could do repeating characters in a row at each turn. The print will be starting and ending at any place and will cover the original existing characters. Okay. Um, okay. I think so. It's something like in so it's just the number of turns. I don't like the word turns because for some A's in my at least for this problem in my mind for turn I mean like literal like turning left and right, so that's why I was reading it really confusing. I think it just means in this case it just means each step. So in each step you could print a lot of characters and then try to print them in a minimal case. I think this is actually roughly so yeah, I mean, so this is definitely a dynamic programming slash memorization problem. I think the yeah, yeah, and I think the biggest length is n. I think there may be a little. I'm trying to think how to kind of best uh, 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 do it. I think, to be honest, I don't know if I want to do this problem only because on Wednesday I think I literally did a problem that is very similar. I mean I could recap that one, but I think the idea is that you just divide them into sub problems, and yeah, and yeah, maybe I'll do it anyway. Okay, fine. So yeah, so I'm trying to debate about we should do this one because it's very similar to the last hard that I did, which took way longer time. But hopefully, I guess this is a chance for me to prove that I can learn from last time a few days ago and kind of maybe do this a little bit faster. It's similar, but it's not quite the same. But basically, this is definitely a dynamic programming slash memorization problem, and in these cases, and some of the hint is that the string is less than 100 or will not exceed 100 or less, which generally points me into a worst case n cube solution or n cube space. It could sometimes be like a slow n cube n to the fourth if you're doing really minimal stuff. So that's like the max complexity I would of an algorithm I would look for. I'm trying to think whether two or three states is necessary, and what I mean is, or three-dimensional or two-dimensional. Um, Definitely, you need the left and the right to kind of like, and then start sub counting the problems. Um, yeah, yeah. So, yeah, the other thing I might consider is, there's some sort of greedy solution that greedy is. For me, my intuition is generally not to go greedy only because, I mean, in an interview setting, maybe I would kind of consider it and be like, hey, maybe I'll think about greedy and these. But I think in general, I don't lean toward greedy unless there's a really strong intuition around it. Because for me, greedy means you have to prove it correct a little bit, and it's really hard, at least for me, to come up with proofs for to prove myself correct. Where for dynamic programming slash memorization, like in a sense, you're basically trying every combination, right? And if the time fits in every combination, then you could uh, uh, then you prove yourself correct because you've literally tried everything, right? And I also, and this is a little bit meta for these things, is that like if n maybe it's like 10,000, then I would actually consider, or something like that. I would maybe consider greedy more, just because like, well, an n cube solution, which is dynamic program, won't be cut it. But so these are things that I would go through my head, just on a meta sense. But the code, so this is also one of those problems where the coding, I mean, I know I'm talking a lot, but the coding will just be, there's actually not that much lines of code, that many lines of code. The hard part is kind of figure out what to write, especially with memorization, where, I mean, you're probably doing like 15 lines or something like that. I mean, maybe a little bit longer, but like 15 units of dots and like, or for loops or whatever. But so that's why I'm spending some time just making sure I'm right. But uh, and some special cases I'm considering is, well, I mean, they gave you very basic cases where, like, yeah, okay, you could do like go from this to, ABA, but a more complicated case that I would be thinking about would be like someone like uh, A. How, so in that case, how many moves do you do? Well, would you? Well, okay. Well, in this case, it's three either way, but you could do either like, you know, uh, uh, oh, you could break it down to uh, ABBA, ABABA, and the other way to kind of do it is also well, it starts up the same ABAAA and then ABABA, right? So there are two solutions for this one, but you can imagine like uh, um, like another case where you add a little bit more, and it's not quite clear where you should start. But I think actually in this case you're only looking for the minimum, so you can actually try them more. I think for the other problem I was doing some. What was I doing? I don't know. But okay, I guess I'll just leave this up so I could kind of have a thing to think about. Uh, but actually, and for these problems, I actually for dynamic programming, I have a soft spot for C, just because then I could allocate the rate quickly. Oop. I don't know how Leetcode C kind of works with standard in and stuff like that, or like global spaces. So I'm gonna see if this works. And in this case, you can dynamically whatever. So I'm gonna just do max. Let's start with 2x, two-dimensional array. Max is just chosen something to be clearly bigger than 100 and now off by ones. The answer is probably like 101 here, but now I don't have to think about it. I am articulating it though. Cool. So you want to do something like return min turns, I mean like left, right. I mean, in this case, I could just pass s. It's just a pointer. So, okay. So returns ls and left and right, and I realized that this makes no sense. Also, switching back and forth between languages. Okay, so the recursion is set up so that like given a min turns of this substring, what is the minimum here, right? So for memorization, I would ask or think about what are the subproblems given this string? How can I, solve it in terms of the previous? And I think the easiest way is okay. So I think my intuition is okay. Well, I actually forgot to set to. Oh man, jumping between languages. Been doing Go lately, so you'll notice some Go-y stuff. Though that's not even true for that one. I just don't have to brackets for it. It's not Go syntax. It's just I forget the bracket notation sometimes. As you go to, so I would say, given that so here I'm setting up the senator values. Given that the length of the string is less than 100, actually the worst case, even if you're the laziest printer, you could do one character at a time. So your max is like your worst case is max, I think, right? Like, or max being 105 in this case, but like in theory, okay, maybe I'll make it clear. So let's define infinity as equal to 10,000. So that it's slightly less confusing. Otherwise, I may confuse myself later. Okay. Okay. So the first step is if TP of left right is not equal to infinity, then you just return. Actually, not. And at this point, I'm actually not so that it's only 2D. I'm still working in my head through it. I think what makes So I think what I'm thinking about is, okay, given a string, oh, did I change language? Something, where did my A, B, A, B go? A, B, A, B, A, B, A. The obvious thing is to trim the two A's, and so that's at least one turn, because basically you strip the left trim and the right trim of the same characters, and then you do a subset of that, but then and then you curse in the middle. So that's the kind of the base case. Okay, let's type that up first. There'll be more cases, but okay. So let's set min is equal to infinity first. Doesn't really matter, I think. So min is equal to min turns of still s. Left. It'll be new left and new right. What do I call them? That's just left trim, right trim, and then this plus one, because you just can do that, right? So these comments I actually use to kind of remind myself what I'm doing, because my brain is not big enough. Also, is min a code word? I don't remember anymore. Okay, so that's kind of the base case. I mean, I'll actually write the trim code. Oh man, I'm really bad at this. First is equal to no. Okay, so now while yeah, because I'm doing this because I don't I mean, you could probably do some recursion on it so that it takes that into account already, but I cannot conceive a way in which like you wouldn't want to chop off the ends greedily for this sub problem, right? Because like, would there be a case where you want to print these things later? No, I don't think so. I mean, at least that's my intuition. So while let's press what is equal to first. There should be more statements here, but white trim white minus, and left trim is okay, and then we'll do the left. Well, I guess same one actually. So okay, and then at the end we want to return the. You could actually combine them into one statement, I think, but I just for slightly readability. Okay, so I know this is not going to be right, but I want to make sure that uh, I just want to see that I'm doing the right thing at least, or right direction for this part for the base case. Oop, language. Sad face. Oh no, overflow. Oh yeah, because I forgot to change the base case. Okay. Um, base case is if left is equal to right, then just return 1. It may be 0. Let's put 1 here for now. Hmm. Oh, I guess you don't always trim. So, okay. No, you always trim 1, right? That is odd. Okay, well, let's put this at 0. Okay. So, you always trim the first character because this should all. Oh well. Okay, well. Man. Okay. Well, I mean that output is just lucky, but or maybe not even lucky. It's just actually, I mean, it is lucky in that like the trim actually just gets rid of A and then gets to B, right? But I think it actually does that well. It takes 0.5. Maybe I could print a little bit more just for just to kind of show my mind a little bit. Yeah, so after trimming, it goes to 3.5 and then 3.5, and then it trims to right first. Don't know how I feel about that. Maybe I could trim left first. It doesn't really matter, actually, I don't think. It might add a couple more results on the couple more tables to DP, but should be okay. Okay, so this is the kind of like the. I mean, I wrote it kind of recursively and so forth. But you could kind of think of that as the greedy algorithm, where like you just kind of start trimming from the outside in, and then recursively do this way. Where okay, actually, I want to try this case, and then okay. Oh well, I mean that's fine, but I forget to print. Oh no. Okay. Yeah, so the 11 it trims to 4 to 8, which I guess is here, and then it trims to a little, and then trims one more. So the output is 3, huh? But the expected is 4. Man, I wish they didn't tell me the answer though. But 1, 2, 3, 4. Okay. I mean, it just maybe means this, but then the other answer may be wrong. Is that right? The reason why this is actually like a bad wrong answer or expected, this is also why I would not like to get a hint on it, is as a result of like whatever greedy algorithm we're doing should not be better than the optimal answer, right? So that's why that feels a little weird, especially since now we go back to A, B, B, B. Maybe there's something weird the base case, see? So there's definitely something weird the base case. We have to make sure that it is right. I think the reason is just that if we trim to nothing, we don't make a distinction between 0 characters and 1 character with this left right thing. I just want. Uh, okay. I mean, how do I want to solve that? Okay. So this is the one trim, but left trim it goes to right trim. Sometimes in one means there's 1 character left, and sometimes it means no character left, which is why it's a little confusing. But I think I could just do this by doing this. But I don't want to do that though, because I think that might lead to off by. Okay, fine. But I think I could just do if. Uh, so okay, let's assume there's no character left, but so what is so left trim is the first character that is not the same of the first, and right trim is the opposite. I guess. I think I could do something like this. If the left trim goes. But basically, I want to say something like if the left character is still equals to first character, that means this condition is true, which means that there may be 0. Oh, I guess in this case it should be 1, and this might have gotten it backwards actually, but we'll see. Well, this is okay. Now I have to check my crazy case. Okay, so yeah, yeah, yeah. I think yeah. So I mean, obviously this is not solved. I still have ways to go. But it for me, it's important to kind of test each step of the way to make sure that my oh no, whoops. But yeah, check each step of the way, because otherwise if I have to come back and kind of debug this way messier, as we kind of find out last time too. But okay, good, it's safe, because otherwise that would be kind of a little sad incident. Cool. Okay, so that's the kind of it takes care of the trimming case. Now I'm trying to think about the case where well, something like like this. Well, how do you want to do it, right? So how do I break it down? So so now we trim this to this. But what is this problem? The problem is that given this, the last character is A. So my notation is a little wonky, so I apologize for that. And what that means is that this A and this A, well, and or could be either part of something that's already the background and therefore doesn't need to be painted, or it needs to be painted, whichever takes fewer steps. Yeah, but yeah, I don't know. I mean, I think going back to your point. I'm still trying. You're right in that. Like I can really construct a really good non-greedy case, but I still don't intuitively think greedy is sufficient, just because very few things are. Or like I find that like greedy farms are just yeah. But okay. Well, so the subproblems here is anyway. So either we print B from the beginning. Let me think how many subproblems are there. Okay, so so at least there's one. So we're all given this case now. We're always going to print B. Maybe this is a little bad too, because let's say I added a C in here just for clarity. We're always going to print B no matter what. As part of the subproblem. Will we ever print C first? No, I think we will print C at the first instance, and it'll be part of one of the subproblems. Like if there was a C here, we'll deal with C when we get to this subproblem. we'll never, or it's either that or we have a C incoming from previously. But and also one of the issue I'm thinking is now, and it may make this thing much harder, is which I haven't really thought enough about, is that I was saying, A could be part of the background, it could be already printed, but you could also say that about C. So how do we keep track of that notion? Because is it sufficient? Well, no, okay. I think actually we're okay with respect to the C stuff because I think if C was already part of the background, then an earlier recursion would, or it wouldn't be part of this problem subproblem. It'll be a parent subproblem, meaning for C to be already been used, there would have been like a C early on that gets processed as a problem that would already have subproblems. So okay. So first of all, we trim. I guess we already trimmed. So so in the recursion, let's say we're looking at this part now. So we already trimmed to this. We did recursion on it, but huh. Also, I mean, now I noticed that we could actually kind of compress the string earlier on for for n equals 100. We actually don't really need to make this optimization, but it is still a true observation. Is that yeah, you could compress the string by the ones of characters, and then it's just about, and maybe that. I mean, you don't need to do that optimization in terms of complexity, but I do wonder if it's the same problem that I mean, I do wonder if like it makes the problem just easier to solve, and like especially with weird edge cases and stuff like this, like the one that I just did, for example. But but I think for now I don't have to compress string. Maybe I could. Nah. Well, let me think about this for a little bit first, or the next step of what to do. So now that we strip this to, yeah. So okay, so what are the states here? Oh, where am I at? Because I think that I think the two of them. One is no. I think this is only for so. Uh, so I think this case in this case, left trim is you go to right. Always going to be left trim equals to right trim. So yeah. So this would always return just 0 or 1. Sorry, and whatever we do next doesn't really matter. Even though I guess we could return early. Um, but then it just for the memorization sake. Um, okay, so now because we're still thinking of A's context. No, so I'm wrong. So I don't have the trim. It's not trimmed yet, but now I'm thinking. Okay, let's break it down. What if this was printed? Then the thing that I'm trying to think is for these A, like I'm trying to figure out like what is the. Okay, so I think this is the thing that I would learn from the last time, which is that I think I'm trying to do too much, but I could actually just pass in the last character or something like that, maybe, and kind of add that as part of the trimming, and then just do it consecutively. Okay, so I think in that case I would need a third dimension. Um, so I mean, if you if you saw my last stream, you actually noticed that I made this roughly the same realization a little bit later, but hopefully this time I am a little faster because, well, it has the same kind of philosophy. It's still a little not crystal clear in my mind yet, so give me a second to kind of form that. Like last time, I'm trying to think also if so there is this concept of, should it be a character or should it be, and what does it mean? So reusing an A from an earlier time means that um, reusing an A from earlier times means that you effectively split the subproblem, but also try. I'm I think the thing that issues last time is that, like, if you just look at the A delimiters, right? If you look at A as a delimiter, so you have like, you bucket them by this. I mean, maybe just slightly easier to see. And you see there's 3 buckets, and with 3 buckets, there's 2 to 3, which is 8 combinations. So how do you, and if you're gonna do subproblems that way, you have like crazy, explosion of combinatorial or whatever. You just get a big number, is what I mean to say. And what we did last time was just kind of passing it through, so that in those cases we don't print the we don't count that as an additional print. Okay. So this may not be an int. This may, can it be an int? I mean, it could be an int in that that's the index, but I don't even think it is necessary. I mean, I'm trying to think. So the alternative of what I'm trying to think about is, instead of k being an int, is that because it's just lower English letters, it could actually just be one of the 26 letters, and if it's an A, then you kind of do it. I'll kind of, maybe it's easier to visualize a little bit. I'm going to use 30 for max alphabet. Okay, fine. Maybe I'll do that. And you can probably, oh, whoops, did not use that. And then you have something like for trim, maybe equals to. Again, I'm very mindful of off by ones. There may be an off by one here somewhere. I mean, not sure how I want to express this yet, but just see. But yeah, so the cost. Okay, so if s of I, as you go to k, I have to do something like, and if I was interviewing, maybe this should be helper. K, if this is equal to k, then you do a cross as equals minturns as in this case I have to do first left trim. Oh wait, whoops, no, actually yes. There will probably be 1 in terms of this plus in terms of, because then you have to print the left and then the right to take advantage. Okay. Yeah. What am I doing? Oh, something like this. I mean, we'll look for 1. Plus 1. I think this is roughly how I. Oh, well, I missed a letter. So, oh no. kill the window. Oh, there we go. Uh, so I have so I think there's some more things I have to massage, but because we don't consider K here, uh, and this would default to name, so default to letter A otherwise. But huh. So I think that this is the general idea, but you know, if cost is less than min, min is equal to cost. I mean, this is roughly right, but there may be some. I mean, the overboarding stroke is roughly right, but I think there's some massaging of making sure that I do the right things, and also because I've been commingling first and K, so this is equals to first, but as you know, we don't take advantage of K in that case. Let me think for a second. Hmm. Yeah, so I think this is definitely on the right track, but mostly because I did the similar problem last week, a couple of days ago. But dynamic programming problems are hard, as you know. Um, okay, but I think I have to reconcile in my head what the first character and the K take advantage of. So I think this is actually roughly okay, but I definitely do not take advantage of K. How do I take advantage of K? But there, okay, so what does K mean? K means that um, K means when I break this part down, I could both take advantage of the first A and the second A and both combinations. Um, hmm. So I think the trimming doesn't really matter as we mentioned, uh, but okay, okay, I think I got it. Maybe I think I've been mixing them together, but I think if Si minus A is equal to K, in that case we because I've been mixing them up a little bit, but this actually so um, for this case, this is for uh, now splitting B's. Oh, whoops. And well, for this case, I think this is oh man, uh, splitting A's from oh man, what the A's from recursion, something like that. Um, so cost on interns. Uh, Again, I know that there might be some off by ones, uh, and the difference in this case is that in this case and this case is that I don't need to do the plus one. I think because you already have the A. Sorry, in our if you've been following along, you know that's a little harder to explain. But that means we're using this A that like we already painted the A, so you don't have to do a plus one to break it. But here, you need to print the B to take advantage of it. So that's why there's the plus one here. I think that's roughly my logic. It definitely is. I have trouble explaining it, so I think I'm have trouble convincing myself as well. But that's kind of And I think the kind of tricky thing is kind of coming up with test case that will illustrate this well. Because the earlier cases that we had before, it just worked for the default solutions. But okay, let's at least see if the code compiles, see if there's stuff like that. Oh yeah, I forgot that I added a dimension. See, so k is still k. So yeah, let's see if the code compiles. See with recursions, it goes in infinite loops and stuff like that. So okay, cool. Well, not totally happy about that. Did I change something? 64 million is not what I would have expected for the number of changes I need to do. I probably, oh, well, in this case, I didn't do cost equals min, but that's just an additional bug. Again, I really dislike that they tell the expected answer. I just want to, like test basic things. For me, it feels like a cheap hint, but I guess that's fine. I just maybe I get used to it a little bit. And we set them to infinity, okay. And this doesn't actually even need to be n, but this is, oh, actually this is wrong. Whoops. This should actually initialize max. That's probably why. Oh man. So actually, full disclosure, when I used to do program contests, I used to do something like memset dp or dp, and I usually do it that way because it's just much quicker to type and less error prone. But it's probably not like Queen style, and I think it's they give you a warning and all that stuff. So and so I've tried to be slightly better. Okay, so there's still an error, but okay. Well, not an error, but don't know how they got that from. Because even if we just do this, it gives us less than that, right? So what did I not know how to do min? And okay, now so there's still some because I do negative because I don't cache correctly. Well, that's one though. We have to not do -1 in that case. Because this is the free character, so let's do 35 because it's 36. Fine. Let's use max alpha -1. Yeah, okay, fine. What line is that? Oh, def 97 out. What? Why is K97? I probably passed one of the I didn't even do recursion yet though, but I forget to mine it. And this is why we need a helper. Okay, fine. Just for short for convert. Paying for now, but that's fine. I mean, I'll get to reuse it later for sure. Oh man. Okay. What? 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 No, I don't. This is there. It's there. Nope, it's not. Oh, it's this one. Oh man, I think the auto parent like if you do this, it actually eats the parents. Like it ate my last one. Curses. Okay, so at least it doesn't choke, which is good. Is this C? Why? Oh man, I've been using Python commenting, and actually I didn't know that it doesn't. I guess it. Well, that's kind of actually wow. All this time, you learn something new every day. I thought they would just give me compiler. Okay, so that's fine. I mean, I expect that to be a wrong one. Well, actually, the bigger one even. But does this really take 6? One. Probably, I guess, because of the extra C. Okay. Just want to understand a little bit. If they're going to give me a hint, I'll take it. All right. Let's see if this helps a little bit or if it. Okay, so there's a Stack Overflow. There's probably because I didn't do a base case somewhere correctly. I mean, I only have one base case, so there may be other one. No, I mean, it should be okay. Maybe I just don't cache something. Well, I mean, as I mentioned, there's probably an off by one here somewhere. Also, is this the right? Nope. Yep. In retrospect, oh man, they ate my thing again. Retrospect, I could probably clean this up more a bit. For now, man, this case already input. Okay. Oh no. Um. Okay. Well, that's awkward. But again, there's probably an off by one that I'm having issues with. Especially like all this stuff. Like I think maybe this is I minus one to because it eats that character. Also, I guess I could. Okay, well, this is the part where I use my trusty debugger to print statement. But let me fix that first. Wait, does this have to be converted? Yeah, sure. And first is a character. Oh man, I think I'm confusing myself now. Oh no. Oh yeah, this should not be that though. So this, though I didn't want that, and it still should stack overflow because it's stack overflowing on this part then. Okay. Well, let's break it down one by one first. We'll just debug the first part. Okay, so there's definitely a stack overflow on this chunk, which means that we're having some stuff calling itself. Okay. Well, let's see what you're gonna give me. 35. Oh, that's just the default. And then, oh, what's 8? So left is higher than right. Okay. How does it get into that state though? So we could check for that for sure, but I want to make sure that, well, because I do some quick. Okay, fine. We just return 0. Okay. Well, at least it's not crazy recursion. At least for now, let's not print stuff. A lot of recursive steps. And okay, let's see if it's okay with the other part. Okay. So this is still definitely very wrong and wrong in the wrong direction, and that this So I assume that when I do this will really there may be some assumption in this part that's wrong. Because what's my input? Oh, that's my input. It could also be an off by one somewhere, I guess. The right is okay. All right, back to the drawing board. Okay, but I will take what we said earlier and at least compress the string so that's easier to read. So this actually I could even probably do a simpler case, but let's just do ABA. Okay, so that works. Let's make sure that our base cases are not dumb, otherwise then it'll be easier to debug. Okay, well, I think ABA is the other one. Oh man. Okay, so this actually is a great test case because it gives us the wrong answer. I guess sometimes you got to hunt for the wrong ones. Um, okay, so man, my print statement is not readable now that there's 5 dimensions to it. I guess the trim. Can we leave out the trim? Okay, so it goes the entire way the first time with no previous things, so this should never trigger. And then it strips 1, 3, so but with the last K being A. So we noticed that, and when we did ABA, it was correct at 2. So, okay, let's actually see what it's returning. Actually, well, I think I want to do it a little bit earlier. So I actually would expect further recursion, but maybe it just recurs on one character, so that's why it's returning 1. Let me double. Okay, let's just see what it's returning. This so this returns 0. Nothing should really return 0, as you know. But what does it call? This, so k is equal to 0. So it cost it goes down to so the base case. This is the BAB case. That should return. This should return correctly, but I think this base case may be a little suspect. The way we're phrasing it. Maybe I could also just write this in a cleaner way. Because because with I as you go to left trim, this was always going to be less than left trim, but then is 0 really the right one? I is equal to left trim. Now this should never happen because then that should have split it from before. I think I know. So this caused this, but this gets a 0, even though it should at least have 1. Because it returns 0 because this and this both return 0 because is that even true? What if I is equal to, so I is equal to 1 or 2, I guess actually. I is equal to 2, but left trim is 1, so 1 1. No. Oh. So yeah, so I think we're stemming from the base case is having some issue. So we don't do a +1 because we spring the A, but we're not getting the cost of the 1 character thing. But left is equal to right is equal to 0. Okay, well, let me just. Fine, let's add it here. That just. I think this also possibly the base case should consider K. That might be a thing. Okay, so there's more output. So the 1 3 goes to 1 1, which is fine. I approve of that. And why does this returns a 1 and this returns 1? So why does this now return 2? Is this mucking it up? Do I need that? No, I need this. Otherwise, it just... Do I? Yeah, no, this has to base. Maybe not for this particular test case, actually. Let's just see if it returns the right thing. Nope, so this still gives an issue for a bunch of stuff. Okay. Let me look into that a little bit. Okay, so this should definitely return. Oh, I've been looking at left and right, but not left trim and right trim. So actually, this should, okay. So I think this should be left and this should be right because you don't, well, because in this case you don't trim it because you're looking for A's and not B's. Okay, let's see if that give us a better feeling. There might be still some issues, but with okay, man, that is an annoying one. Okay, let's play around with at least the test example so that we're not, blatantly wrong, and hopefully, unlike last time, I actually take a look at it before. Man, I have some like bad stuff, things going on here, but I guess I already tested that one, but okay, that looks good. This looks good. And usually I don't do this, but I'm going to just take but I guess that's part of Leetcode, so I'm going to just test random code and see how it compares to their judge. Because usually, or not usually, but like in other contests that I'm accustomed to, they don't give you the expected output, so it's a lot harder to figure out. So that's, I mean, let's just try a big random string. Okay, so everything looks okay so far. I'm still not confident just because it's a little tricky, but I don't know. YOLO, right? Is that what the kids say? Fingers crossed. Maybe we run out of memory because it takes so long. Uh-oh. All right. Our bounce I could handle, but... oh, no. Oh. Man. It's the empty string that gets... I feel like I do a lot of random stuff and then I mess up on the stupid stuff because n is then 0, but... Oh, my God. I'm not even going to fix this. I mean, like, I'm going to fix it, but I'm not going to do anything dumb. I guess 0. Okay. YOLO. Okay, well, man, really bad on the test case today, edge cases today. I mean, this should just be 1, but why did I return 1? It's probably a left trim, right trim thing where, because I right trim first, this becomes like -1, so then it goes 0, -1. Oh my God, what a silliness. I think oh my. Oh. Okay, well, YOLO except for the 3rd time, I guess. Okay, so that got accepted. Whew. I mean, that took a while and it's kind of fun actually. I mean, and I guess I did a little faster than I did last time I was doing the similar problem though. So I am learning, so that's all you can ask for. Yeah, so there are a lot of kind of mental mistakes that I made on this one, especially near the end with the 2 runtime errors. I mean, those are easy quotable things and I should test more. I think as with most dynamic programming / memorization problems, the trickiest part is just trying to figure out a way to to kind of try all possibilities. And it requires you to think about what all the possibilities are. And I think that's why and some of it is based on the constraints. It's a little bit of a hint, to be honest, but I prefer that. Like, if I'm not convinced about greedy, that's where I would go. But because in theory, if you try all possible, ways to do certain things, then then you prove yourself correct because you literally done everything, right? I mean, that's the way I think about it. Cool. So I think, I mean, that is the lead code problems for the day.